what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by The Plain Truth, Sleeping Warrior, Ranty Flat Earth, Jose and Arwin. Good to have you all.
Yo, yo.
Beep, beep.
Good afternoon.
What up?
Go back to the example that we had before.
Oh, sorry, that was me.
That's all right.
Carry on.
Let's do housekeeping. Any signs of curvature?
No.
No.
Any signs of
No.
Earth-based axial rotation?
No.
No.
Any
Sunsets.
proof? Go on.
No.
What was that? Was that a yes? Did I hear a yes?
Yeah, I've got somebody telling me that sunsets are proof that the Earth rotates.
Really?
Sunsets?
Yep. It can't
There may
happen.
be some
Sunsets
ether-based
can't happen on a
rotation.
flat Earth. The only explanation is the Earth is rotating. Otherwise, you would never have sunsets. It's amazing.
To be honest, it's the only thing that makes me possibly consider the possibility that we may be on a spinning Earth.
You have a
Sunsets,
laugh.
the only thing. However,
the
I also
sun
realise
moving.
that just because we can't explain it, doesn't make it that that doesn't mean by default that the Earth spins.
Yeah, that's what I'm trying to get him to come around to. I'm just like, look, we don't have. Yeah, it's the whole thing where you have to have your T's crossed and your I's dotted. They can't have ambiguity at all. No mystery. So anyway,
Any proof
that's
of
what I'm
gravity?
working on.
Any proof of gravity?
No.
No.
Yo.
Any evidence of a molten iron core at the centre of a self-perpetuating... No. Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth? There you go.
No.
Nobody?
Well,
No.
I thought Jaren had this evidence.
Yeah, I was going to say that. I thought we'd taken that off.
Yeah, we don't use CGI evidence. If it looks like CGI and probably is CGI, then we can dismiss it.
Okay.
That means rockets are out of the question, unfortunately, Reds.
That
Sorry.
means that all my footage is out of the question too then as well, yeah.
Yeah.
No. Your footage, joking aside, is not CGI. So, no.
Oh, it is because Awake Souls has said so. The reliable source that he is.
Yeah, the same reliable source that Pete Shea quoted for believing in Patricia's being a man. So
Yeah, and let's put something into context, right? There are people that seem to be picking up on the fact that Nathan had questioned his quote source, rather than looking at the answer he gave, which was his sources. Nathan used the wrong word, right? But people are picking up on Nathan using the wrong word and trying to claim that he misquoted what's his face, Pete Shea. And anybody that's doing that is disingenuous. He was asked the question, which people does he believe? Blah, 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 blah. And the answer that he gave was Awake Souls and MGTV. And obviously we all laughed. But the point was, they are his sources. They're his cited sources for why he believes his views that he does. So to question Nathan on the application of the word source, even though it might not have been the perfect word to use, it still makes the point. So stop distracting away from the point that he accepts the views of Awake Souls and MGTV when we all know that this is nonsense.
yeah, they're not credible.
No.
Awake Souls certainly not.
Any evidence of gas pressure without a container?
Well, we're waiting for a video from Conspiracy Cats on that point. Now, he's been on for a while. We're waiting for this for a while. Still no response. I think he's waiting for Nathan to bow down and kiss his feet in some way, because he seems to be ignoring the protest. He seems to be repelling the attack by saying, until you behave, Nathan, until you behave, Nathan. And the reality is, there is a contradiction in the scientific model that needs to be addressed. And as a physics teacher, Conspiracy Cats is expected to come up with the answer with evidence to prove it, not just a mathematical formula which he's going to draw on his whiteboard and a couple of dots. We need to see proof that this is actually true. So he admits that gas is released into the atmosphere, into the space every single day. That he's quoted as saying that. So therefore, the system must be open by definition. And if the system is open by definition, that creates a bit of a problem for gas pressure. So we're waiting for Conspiracy Cats to get back to us. And I'm thinking he might be running, Nathan.
Maybe. I wouldn't be surprised, because the task that he's been set is falsify the second law of thermodynamics. Good luck with that.
Yeah.
Has he still got the little teddy bear that he's put on the side? The Teddy Nathan?
I don't know.
No. Attacks on me personally, I couldn't care less about. Show us gas pressure without a container.
No,
Yeah,
he's got a little teddy that he's going to stick in every one of his videos, and apparently that's you.
Yeah, but he's doing that because he's trying to make personal the attack, which is on science. So he needs an escape route, right? He needs to attack Nathan personally to make it look like Nathan's being unreasonable. But actually, Nathan's not being unreasonable. There is a contradiction in the scientific model that you guys believe to be true. That is, you can't have the gas pressure unless there is a container. So how do you get mass going into space daily? And I mean, alternatively, I mean, what's replacing that lost matter? That's the next question I would have. But if gas is being lost to space daily, as he says, then it must be an open system, and therefore you can't have any gas pressure, because you need that gas pressure for us to be able to live. So how do we have that without a container?
You'll just share my screen, Nath. I'll show you the little teddy that he's got for you.
Yeah.
It's a cat.
It's a little pink cat, I think.
Does this somehow demonstrate gas pressure without a container? Does this somehow falsify the second law of thermodynamics? Does this somehow prove that we have a vacuum of space? Or is it just a teddy bear?
It's just a teddy bear.
Oh, right, great rebuttal.
He's personalising it because he doesn't want to. Well, I'm not sure what he's attacking. I don't know what he's trying to do other than swerve the question. And I think he's doing what the ballers generally try and do: hope things go away. And I'm like, well, not really. Don't make it personal. He's not making it personal to you. Yeah, he's attacking you, but it's not personal. It's all about your model that you believe to be true, sir. So where's the physics for this?
The physics for how we have gas pressure next to a considerably lower pressure system that nobody's ever been to or experienced. That would be outer space. So how can you have gas pressure, something we all experience, I'm breathing it right now, without a container? According to the system that you believe in, your heliocentric religion is an open system. You think you're going to the moon, right? You're not. But you think you're going to the moon. Well, that's an open system. Matter is being transferred between the two systems. Therefore, open. So if you don't have a container, you don't have gas pressure. And yet we do, defying the second law of thermodynamics. Now, we would simply assert that space is not real. Nobody's ever experienced it other than a load of lying Freemasons who present it to you on a television screen. You're not going to go to space, but we definitely have gas pressure. And a necessary antecedent for gas pressure is a container. So, Conspiracy Cats, lovely teddy bear, how do you have gas pressure without a container?
And videotaping a rocket going up and up and up from the distance, that's not going to show gas pressure without a container. Just in case if somebody want to propose and showing a rocket, unless, I mean, I don't know, what can they show? From Earth, me standing here videotaping a rocket? Nah, I don't think that's going to show it.
Any more outstanding issues, Nath?
In terms of housekeeping, yeah, any evidence of the presupposition itself, so any evidence of R.
No, Mick West admits that R is a presupposition.
That's
or
right.
an assumption.
So any evidence of the presuppositional value of R, gentlemen?
No.
Still just a presupposition. Fair enough. What about distance to the sun? Is it still based on the same presupposition of the Earth radius, and that being the same as a light in the sky they call Venus?
As far as I know, it's still based on Christine Huygens' citation or the assumption that he assumed that Venus was the same size as the Earth. Now, Simon Dan or no Simon Dan is supposed to be doing a response video, and as yet I've not seen anything. And I'm just wondering why he hasn't got back to me yet, because he's surely back off holiday by now. Anyway, so no, I think the answer seems to be no.
It's the size of my finger.
Yeah, Venus is the size of my thumb, yeah.
Yep.
That's lovely. So no evidence of the distance to the sun?
Nope.
To be honest, it's a fair analogy because all that we have, as far as I can see, is the relative distances to each other, the relative scale. We don't have any actual measurements. So when Ranty says it's the size of my thumb, that's actually a really good analogy to make because it demonstrates that we don't know any of the distances to anything.
So for the distance to the moon that we have right now, the 37,000 miles away, what was, was it just mathematically knew before they, in quote, went to the moon, and then now they got an actual measurement? How do they know the distance to the moon exactly by inches?
Well, they don't. As far as I can tell, they base it on Christine Huygens' observations in the 16th century or 1600s, early 1600s, where he assumed that Venus was the same size as Earth for the calculations to the distance to the sun. It hasn't gone any further.
But I say to the moon, which is shorter, is closer.
Yeah,
it's based
but
on
once you know the
based on
distance
scale. So once you have one of these distances, and you can say it's this length between this celestial object and Earth, then you've got the whole scale. So you'd have the scale anyway. You just, when you're attributing actual feet and inch measurements to each celestial body, the moon in this instance, you've got to start somewhere, which is where Anthony's backtracked it to Christian Huygens and his assumption that Venus is exactly the same size as Earth, when you presuppose that Earth is a sphere with a given radius.
Oh my, yeah.
I mean, it is relatively complicated. If you know, for us, we can rattle it off because we've gone through the investigation process, so it's obviously cemented nicely in our minds how this presupposition has come about. But for your average audience member who hears those words, they're not necessarily going to A, follow what that actually means, or B, care. They might not realise the implications of what that means. The entire universe, as it's presented, is based on guesswork.
Yeah. Now, if you actually try and research yourself and work out what came first, whose measurement came first, there are many different answers. Christine Huygens is one of them. I've released a video very recently about a bloke from Liverpool that died at the age of 22. But he's been cited as the guy that got the distance to the sun rather than Christine Huygens. But there are numerous people in science that are part of this. I've got the distance to the sun sorted out. So it's which one's true. And there's that many of them. It seems to deliberately confuse and obfuscate the point. And you end up getting to the end of your decision by thinking, well, there's numerous citations here for which one's believed to be the source of the information. You just don't know what the truth is. And in the end, I had to ask people within Flat Earth, did they know where it came from as far as they were concerned? And literally, there is no real answer to it. So when you start looking up who worked out the distance to the sun, what was the method that they used, etc., you end up never getting an answer that's consistent across the boards, across the references. And ultimately, you always end up back with the radar calculations to and from Venus, right? Which are complete. And I'm hoping that Simon Dan comes back with that as his response. But you end up back at that. And you end up ultimately thinking, I have no idea who got the distance to the sun. And that seems to be deliberate. It seems to be the intentional cause to obfuscate the point. If Google is the font of all knowledge that everybody claims it is on their side of the ball, why is it so difficult to find that answer out? Why is it all inconsistent? Why are there multiple citations from different references and none of them are all the same? It should be one bloke somewhere that worked it out based on whatever method that he did and blah, 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 and they should all be consistent with each other, and it's not. It's numerous different people from different time periods in history, and basically the answer is you can't find out what the actual truth is, which is a problem. Science is supposed to be beyond critique. Anybody that challenges science, how dare you? But that's not my experience when I was trying to find out who worked it out.
Yeah, you can make an accurate guess. You can make a guess and mathematically,
Hi, Eric.
try to get to a
Hi,
conclusion.
P.
But if I
How you
want
doing?
to know how
Hello.
far the house is, I gotta measure it. I gotta make a scale. I gotta make a scale. So I gotta grab a freaking rake and I start piling it up, or get a measuring tape and measure it. That is the only way to get
Or
it 100%
alternatively,
accurate.
Jose, what you could do is you could look at a light in the distance and just assume it's the same size as your house and just start there.
Yeah, yeah, I know, right? That's ridiculous.
I have got a short demonstration I want to make, Nath, on density and buoyancy and gravity.
Go on then, do it now before it all kicks off.
And just for the benefit of Arwin, that he happens to be on the panel today, this is not aimed at you directly, Arwin, but I'm sure you'll have a view on it, and I'd encourage you to say it if you want to. But I found these two videos, and I just thought these are excellent. So if I just screen share right now, share my entire screen, Arwin, if you'd keep an eye on the back door whilst I'm doing this presentation, it just means that I'll get through it without getting kicked.
Just means you'll get through without Arwen being triggered if he's paying attention to something else.
Well, also that, but not also not getting kicked while I'm halfway through. Right. So basically, this is a good demonstration of basically density and buoyancy. And the question that pervades this all the way through this is, where does the density and buoyancy stop? And where does the gravity begin? Because that's always the query. So in my video the other day, gravity requires a physical force. On screen at about 7:30, I had this on-screen demonstration of separation between liquids. A couple of solids in here, but mainly it's liquids, and they're all identified with the words for what they are. But what I changed the words to for the sake of this particular illustration, and it works really well, I changed them just to numbers. And then if you change everything to a number, you could start with the most buoyant one at the top being 1, and then 2 being the next one, 3, 4, and so on. But you can substitute, once you have them in numerical order, you can then substitute the elements of the periodic table into this. So, for example, number 1 would be hydrogen. And then by 7 and 8, you'd have oxygen and nitrogen, because 7's at nitrogen, 8's oxygen. And then you could visualize our atmosphere being the layers that we know that it actually is, because we're told that we have layers in our atmosphere. So with regards to density and buoyancy in the atmosphere, that's one way you can picture or visualize what's going on in our atmosphere. Now, on that basis, check this out for excellent. This guy is using, I believe this gas that he's filling this container with is called sulfur hexafluoride, if I remember correctly. And that's not me being clever. I'm just trying to remember what he said. But what he's got is he's got the gas feed going into the container, and he's filling up this container with a gas that is 8 times more dense than the air that we breathe. So if it's 8 times more dense, it's going to go to the bottom of the air that we're in, right? But you'll notice that he needs the container to create the gas pressure. That's the first point. But secondly, when he fills it up, look what he does. He gets a single piece of aluminium foil or aluminum foil, depending on where you're from, and he makes a small vessel out of it, and he sits it on this layer of buoyant air, of dense air, and it acts just like water. Now, at this point, what he's doing, I mean, there's nothing in there, right? It's a scentless, odorless, like featureless gas that you can't tell. And if you breathe too much of this, it'll kill you, right? Because it's the wrong stuff that we should be breathing. But he gets a container now, and he starts to pour it looks like it's water with the way he's trying to do it. And he's trying to sink this little boat he's made, and he's trying to flood it with this heavier, like denser than air gas. Now, when he floods it, I mean, you got to imagine what he's doing here, but you can see that he's getting the denser layer of air, and he's pouring it into the gas. And at this point, you can see that it's physically being pushed down. So this is a downward acceleration force, perhaps, but you can see what he's doing, and he makes it sink. So if I was to go back to my layered atmosphere with the numbers, you could give the number that's in this at the beginning of this clip. You could give the number relative to when he's got this thing floating, like there. You can draw a line, an imaginary line across here, and say that the gas below will be given a value of, say, 7. And then the air around it would be the value of, say, 2. And then when he starts scooping out all the 7s and filling up the boat with 7s, that increases the density or the buoyancy, or reduces the buoyancy of the boat to the point where it capsizes. And we can all imagine that without seeing anything. It makes perfect logical sense. Now, bear that in mind in relation to this next clip. which is this is done from the position of nutrition. It's done from dieting and weight loss and stuff like that. So what he's got is he's got 5 tin cans, and what he's asking the presenter, what does she think will happen when he gets these tin cans of liquid and puts them in the water? And he gives her the choice: is it going to sink or is it going to float? And she says, well, it's going to sink. And he said, well, why is that? He said, because it's heavier than the water, which makes sense, right? She doesn't mention gravity. She mentions that it's heavier than water. And she's right. This drink sinks. So he asks her, all right, well, what about this one then? This is a drink called something else that Americans will be familiar with that I'm not familiar with. And
Coca-Cola.
she says sinks.
It's fairly well known across the world.
Okay. But then he says to her, well, what about this one? This is Diet Coke. And she says, well, it'll sink. So he puts the Diet Coke in there, which doesn't have anywhere near as much sugar, but it doesn't sink. So at this point, if we think back to it, and now he pushes it down to make sure that there's no trapped air, and it becomes buoyant. Now, what he's pointing out here is that the difference between the drinks cans is the content of the sugar. So this is like the egg and the salt water example, where you manipulate the egg's buoyant position based on the density, the relative density of the environment it sits in. This is the opposite way around, because we know the tin cans are all the same weight. They're all the same tin can. We know that the predominant feature or ingredient inside the thing is carbonated water. So they're all pretty much the same in terms of the liquid inside them. But we also know that the sugar one, the full sugar one, has got more sugar. And we know that the diet one doesn't. And this is evidence of the density difference between the soft drinks, and the difference here is the saccharin or the aspartame or whatever compared to the sugar. So when he gets the other drinks, some of which are sugar, some of which are diet, some of them float, some of them sink, but you can tell which ones are going to do which, because you can tell just by looking at the density of the object that you're looking at, which one is going to be sinking and which one's going to float. And it's clearly the ones that are full sugar drinks compared to the ones that are diet or sugar-free. So again, this makes the point that it's to do with the density itself rather than the gravity. Now, if it is to do with the gravity, again, the question is, well, where does the gravity stop? Where does the gravity start? Where does density and buoyancy stop? And how would you prove it? Because we can demonstrate the difference between density and buoyancy, and we can manipulate the environments to show that it is density over buoyancy and nothing more. So you don't even need the gravity, even if it did exist. But if it did exist, how would you demonstrate it? Because we can demonstrate clearly that it's density and buoyancy explains everything. Now, I'm sure Arwin's going to say something now. So, Arwin, do you want to respond?
Yeah, same old, same old. I'm just very curious about the exact weight.
Well, what he's showing is how.
No. Hold on. No,
hang on. What he's showing.
No, I know what he's showing.
How much sugar?
I'm watching it.
He's showing how much sugar is missing from the non.
Yeah, I get that. It's stuff being dissolved within it, but that should increase the weight, because that is what density and buoyancy are: the mass compared to the volume it has.
Sure,
basically.
But the volume's all the same, and the mass is governed by the difference.
Of course, the volume is the same. That's why I'm asking. I want to know the weight, because these Diet Cokes, these diet aspartame crap
it would
drinks
millimeters.
Way less.
No, so you'd have the
telling.
same. They'd both be 12 fluid ounces or 330 milliliters.
Yeah, I know, but that's not an indication of weight. It's an
It is
indication
fluid
of volume.
ounces.
Yeah, fluid. The key ingredient is water. Most of these drinks have used water in them, right? They're not fruit drinks. They're based on water, carbonated water. So they've got roughly the same amount of carbonated water. The only difference is between them, other than flavorings and preservatives and colorings, is what you're looking at in terms of the sugar, and he demonstrates it.
I'm just interested in the literal weight, because
Well,
that information is missing.
12 fluid ounces per can.
Anthony.
What the hell?
Hello, Mark.
Hello. Anthony, would you accept that the container is forcing the different objects to share the same space?
Yeah, that's called displacement.
And would you accept that two bodies can't exist in the same space at the same time?
Correct. That's also called displacement.
So the container is actually forcing the water and the cans to share the same space.
So what?
So they're going to be a separation because they can't share the same space. And so the lighter one
That's
is going
not a disputed point, though.
No, but you're ignoring that the water is also subjected to a downward force.
I'm not. There is no downward force.
So you're ignoring it. What's keeping the water inside that space?
I'm ignoring it because you can't prove it's true.
Hold on,
Hitchens'
but there's
razor.
an answer to that.
Come on,
Hold
come on.
hold
Hitchens' razor is a
But
fallacy.
there is an answer, Mark. So the answer is because it's heavy.
Yeah.
So what's keeping the water inside the container?
Because it's
The
more heavy
container.
than the air.
The both bit.
Oh, it's all
in all directions.
The water is denser than the air that it sits in. So
And what's keeping the water down in the container?
its own density. That's why you can't distinguish between the weight of your arm over the gravity affecting it.
Less dense.
Hold on,
The
let me just add
container
one
is
thing.
forcing
Sorry,
the
guys. Can I just add
various
one?
items
Arwen,
to
sorry to
share the
interrupt.
same
Let me
space.
just add one thing. So what you seem to be trying to translate into this liquid is the effects of entropy, which would apply to the gas, but not to this liquid in the same respect. So that's
Are you
what.
talking- are you talking to me?
That's what the ballers.
Anthony just demonstrated that. with
Oh,
the
right.
gas.
That's all I get, is it, Arwen? Thank you very much. So, in the same way that when the ballers argue, well, if you just put your hand inside a fish tank and grab the fish, you can remove it from that system. It's like, well, no, that's not gas dissipating.
You're bringing in
everywhere.
ballers. We're not ballers.
But the liquid,
Come on.
the
Let's
liquid
go back
doesn't.
to what's actually happening.
I nearly
in
got
this
to the end of my
situation.
point, Mark. Thanks.
Okay. Forgive me. Go ahead.
So the liquid isn't trying to escape into the atmosphere like a gas. It has weight. It's attached to each other molecular. I can't say it with a cold. Molecularly, it is connected. It's not separate like a gas. So it's not just trying to escape the container. It's bonded together and has weight.
My point is that the container is forcing the two items to share the same space, and they can't. That's physically impossible.
Yeah, that's just called Archimedes displacement. That's not a contentious point.
But what you're demonstrating here is buoyancy and density. You're not demonstrating an absence of a downward force.
No, but I'm asking, where does the buoyancy and density stop, and where does your gravity perception begin?
Well, I think that's a straw man argument.
No, that is your argument.
Will you explain
a straw
why
man
that's?
argument.
Will you explain why that's my argument, please?
Because you believe that there is an additional force.
Don't
And
tell me
I
what
say
I believe. Tell me what you observe and what your conclusions are.
that there is no evidence of a secondary force.
This is clearly triggered you there, Mark.
No, but density. Are you saying that density and buoyancy are forces themselves?
There's no. I'm saying that there is no evidence of a secondary force.
I have some.
Do you
right
know
here.
of? Do you know of displacement? That does
Archimedes
not.
displacement.
That is physical displacement, moving,
Right,
Yeah,
Arwen,
where a
Displacement's
force is not involved.
I agree
Arwen,
with you
can I-
guys. Displacement is not contentious.
right, Arwen.
I have evidence
And
right
Mark.
here that there's a downward force.
Go ahead, Pete. Go ahead, Pete.
Yeah, I don't want to
So-
listen to me.
Saved by
Yeah, no one wants to listen to you because you have CGI footage. We all know you're
Come
lying.
on.
So,
Pete, you're not going to obfuscate this point right now by whatever you're about to present.
what? So do you see the video I have here?
Yes, please. Go ahead. Show it to us.
Do you see these in this container? We got buoyancy separating these three different liquids.
Hang
Yeah.
on, let me get to it. Hang on. Pete, there we go. Right, I'm watching. Go on.
Okay, so we got three different liquids here separated by buoyancy, and we're in the vomit comment, which simulates 0G by diving. So when we play this video and they go to 0G, we see that the buoyant force is gone and the
Nathan, you're
liquid
echoing.
mixes. You see that?
But now the liquids are falling. So although it looks to the person who's filming like they're all static, this guy's just sat. He's not. He's falling at a huge rate, P.
Yeah, but that's intentionally to simulate the zero gravity.
Well,
The downward force. They've
it's
removed the
free fall.
downward
No,
force.
They've removed the downward force.
No,
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 they don't
no,
remove
hold on,
it.
hold on,
It's no
hold
longer
on, hold on,
buoyant.
hold on,
Realize
hold
it.
on. They're not removing a force.
They
are
removed the downward force,
Pete,
and
Pete,
now
Pete,
there's no
Pete.
buoyancy.
Pete, they're falling. Why would you assert that they've
Yes,
removed?
it simulates zero gravity.
No,
Nathan.
they're falling.
It simulates zero gravity.
Doesn't
Nathan.
simulate anything. They are in fact falling. That's what they're doing in this plane. You just can't see it because there's no windows. But they're moving at a
Nathan,
tremendous
objects in
rate.
Free fall are weightless, Nathan.
No, they're falling.
Also, Patricia Steer is a tranny. Peach.
Oh, gee. So this is your obfuscation technique. They are, in fact, falling. They are moving at a tremendous rate. They are not suddenly weightless, as you call it. Their weight is causing them to fall towards the ground. They're not weightless. They're falling.
But back to the thing at hand, There's two cans. One is a diet and one is a regular. They're both the same weight. They're both the same volume, right? One sinks and one doesn't.
Yeah.
That's the point.
No, that's the point of demonstrating buoyancy and density. And it's
Yeah,
a
but
nice
you went on
experiment.
to saying about things that are sharing the same space, and that's why one fell and one didn't. That's not true.
What, they're not sharing the same space? Does the container not force them to share the same space?
They're in the same environment.
The same space.
No,
remove the container.
Right.
And they'll find.
Right.
Hang on. Remove the container and they'll find the next lower level.
Mark, what you're doing is introducing a straw man argument on a point that we both agree on. Archimedes' displacement is not contentious.
You're using displacement as a means to show there's no gravity.
I'm not using displacement. I'm using its own density relevant to the amount of sugar that's in the container.
Where is the force coming from for this displacement?
What force? Where is the force?
It's a motion.
Remove the container and it'll find the next lower level.
Together.
Is
The
the
force and motion are part of each other.
Oh, and if they remove the container, they'll all find the next lower level.
Right, listen to me. If you put it in the ocean, if you put it in the ocean, if you put it in the sea, what would you say then? Remove the sea.
Well, the sea is contained by the land. Come on, rising land.
So essentially, basically you're just going to bat it out.
Hang on. It's a straw man argument
thing that you can come up with.
Hang on, it's a straw man argument. My question is, where does the density and buoyancy stop, and where does your downward acceleration force begin? That's the question.
It's the cause.
I don't understand the question. Please explain.
You have no cause.
Right.
For density.
You understand gravity.
Gravity is the cause.
What do you mean by gravity?
Whatever you define gravity as, this additional force that you think exists.
So what do you think I understand gravity as?
As an additional force.
Question with a question.
No, you can't call it an additional force. It is the force that causes the displacement within density and buoyancy.
Right, so how do you prove causation for your cause that you claim exists when we can demonstrate the alternative?
No, you have no cause. That's not an alternative.
Yeah, we do.
It is a description. I've said this so many times.
Darwin, the sugar was the cause.
No, it's not the cause. It is just another effect of density and buoyancy that doesn't demonstrate the cause.
The sugar is an ingredient. That's all it is. Not a cause.
You can't even concede that Anthony's got a point here. None of you.
No, he doesn't. It's just an example of the workings of density and buoyancy. An example is not the cause.
Right. No, so, Arwin, you said that sugar was the cause. You said sugar wasn't the cause, and I said sugar was the cause.
It's an ingredient. That's all. It's a variable. That's all it is. It's not.
Yeah, that's right. It was the independent variable that was altered by the experimenter to cause the effect, which was sink or float. So where does the gravity fit into that when sugar, by your own volition, is the ingredient?
The same answer is coming back to you, that they can't share the same space, so they have to work it out between them.
That's a straw man argument.
It's not a straw man argument. It's not.
I agree with you on that. I agree with you on Archimedes' displacement. That's not contentious. It doesn't answer the question.
Can I ask? Hold on. Can I ask a supplementary question? Clearly not. So, Mark, when you put the first can in, right, to the container with water in it, and then you put the second can in, your argument about them not occupying the same space applies to those two cans with the same ingredient in. Then when you put a third can in, the same applies again, but we have a different effect.
They're being contained in a glass container, so they're forced to share the same space. You remove the container, they'll find the next lower level.
Yeah, but what I'm saying is the effect of the first two cans was the same, regardless of the fact that they can't share the same space.
Where?
I don't follow your reasoning there.
Well, you're saying your explanation is, well, because they can't be in the same space at the same time, their effects are going to be different, and it's going to work it out within the container. Well, if that was true, you wouldn't have a difference between the two different properties
being
of the two
forced
cans.
Into the same container because of the glass container, as well as a downward force. There's two things holding them in that particular space.
Right, so we accept one of them, but can you prove the second?
What do you mean? Which one? Which one do you want me to prove?
That there is a secondary force. We all agree on the first one being the container that houses the water or the liquid. You're making a secondary assertion that one of them, there is a secondary force, that one of them that is contentious. How do you prove that there's a secondary force?
I can only speak by observation, as you are observing the demonstration of
directional pressure.
No,
we
it's
go
not
to one
directional,
direction.
Arwen. It's relative. We've had this conversation many times, and you keep saying that that nobody's ever answered your question, and that's not true. We have had this conversation many times. It's not a direction; it's relative.
What's holding the water in the container?
It's not
The
relative.
container is holding the
Going in
water.
the same direction.
Exactly.
Okay, hold on.
exactly.
Let me just add something else. Okay, Mark. So,
Earth
I
direction.
don't know if Anthony can bring up that layer of all the different liquids with the dish soap and the cherry tomato and all that. If you can bring that up just a second, Anthony. If
Do
you're
you
going
want
to
it
say
with numbers or not numbers?
doesn't matter. So that container, Mark, where you think that water is being held by a secondary force, depending on where water was introduced to this layered sandwich of different materials, depending on where you put water into that mixture, or not mixture, that separation of liquids, will depend on whether or not it goes up or down, specifically water. But your assertion is that it always is being held down by a force.
Yes, I observe a downward force. Yes, I do.
Right, so if I put, let's say, in each of these layers, where there's a number 1, 2, 3, 4, 5, in each I'll put a little, like a little bung that I can introduce another liquid into this mixture, non-mixture, whatever you
Say
call
number
it.
6, Nathan.
Oh,
Go with number 6.
Okay, so at number 6, there's a little syringe, and I can inject water in at level 6. Well, that water isn't going to go down because there's a force pulling it down. It's going to go up because it's less dense.
Okay, now listen. If you remove the beaker, what would happen to all those various layers?
Strawman arguments.
What would happen to them, though? Just answer the question. What would happen to them? They would find the next down layer.
Who
That's
cares?
it.
That's straw.
I care. No, it's they're being forced into the same space. They can't mix together, and so they separate themselves with the theory, with the rules and laws of gravity, not gravity, of density. Remove the container, and they will all try and find the next lower level.
Yeah,
I
but
wonder
all-
why.
it's
Why
not
did they find the
relevant right
next
now.
lower level?
All you're doing is changing the scale drastically by doing that. That's not changing the principle.
Yeah, let me explain to you what exactly happens in
No,
that.
I don't want you- I don't
Just
want you to
demonstrate.
explain.
No, I want to
I
respond.
don't want explanation.
I want to respond to this.
I
Stop
want
censoring
to
me.
demonstrate where the density and buoyancy stops.
When you're
and
not
where the
allowed to
gravity starts.
when you're not allowed to explain, you can't
it
have
is.
a con-
Go ahead,
Introduce
Owen.
water, then it might go up because
the
it is
question
less
that I asked-
dense
Anthony,
than
just give him a
everything
chance.
surrounding it. Right?
I didn't hear a word of it. Say it again,
But
please.
that
Say it
doesn't
again, please,
mean that
Owen.
there is a force upward. It means that everything that surrounds it, because of its greater weight, pushes against it. It pushes it back up. That is what really happens.
which is
So
called
it's a
displacement.
directional force, and that with the most match
Right.
will
That's called
outcrowd
Anthony, just
that
it's
with
the
the
end.
less mass.
Arwen, that
The less
point is
density.
not in dispute. I agree with you. That's called Archimedes displacement. That's not in
Yeah,
dispute.
it's caused by a force. It is pushing
remove
motion.
the container, and they'll all go to a lower next level.
Right, and all you're doing is changing the scale. That doesn't change the principle.
You'll show me a picture of all these different various layers in a container, which is an artificial way of holding those things together. Remove the artificial things
evidence-
together.
Hold on.
Evident-
So no, Mark. So if you look at the ocean, it's the same. You've got something that's denser than something that's less dense. The one's below the other. It's just a mass version of this.
And
But
if
the
there was a
same-
massive drought and all the oceans disappeared, all the ships floating on the ocean would go to the next lower level, which is the base of the ocean.
But
Yeah.
why is that though?
Oh, well, you tell me why it is. Why is there
Because
a
the
downward
ship is
force?
heavier than the air that it sits in, so it's naturally going to displace the air below it by virtue of its density.
Yeah, but why did it go down though?
Because
Can I
it's
bring up a point?
displacement.
No, it finds an
Not
equilibrium.
down.
It's the next lower level it finds because there's
It's not
nothing
down, though.
resisting.
It becomes
hold
a
on.
combined
Hold
object.
on, Arwen, sorry.
Alright, so why
hold
do
on,
helium
hold on,
balloons
hold
go up
on.
then?
Hold on. You're
I
saying
think-
the next lower level. So you're defining it with a concept, Mark. That's a direction.
It's an
Lower.
observation. Come on, you know that.
No.
Nathan,
You haven't
it's the
acknowledged
next
what I
lower
said,
level it
Mark.
finds.
Mark, you haven't acknowledged what I said. So if we put a syringe into this, yeah, and we put water into it, it will go up if you put it in at the low enough level. So its density will displace the things below it and go upwards. But you're saying, well, no, the direction of travel is down. How does it sink to the level below? Well, you're attributing a direction, and it's purely based on the density of the thing disappearing.
But what happens when you remove the container? There's no syringe in this picture. You're introducing a syringe. I'm going to take one of the
just go
items
to
of
the
this
next
picture out. Anthony, hang on. I'm going to remove one of the things in this picture, and that's the container, and they all find the next lower level.
Right. So why do helium balloons go up then?
Eventually, they
Because
come
they're
down
pushed
because of entropy.
Right. Right. That's a different point. Why do they go up?
because
Hold
they're
on, but
pushed
Mark,
up.
hold on. If
pushing
you
them up.
smash, hold on. If you smash this container, yeah, and
Yeah.
there's water and there's milk, and the more dense water happens to be still sat on top of it, it will still sit on top of it regardless of there being a container there.
Yeah, that would be, what's that called? The
Density and buoyancy ratio.
no.
That would be your next level.
the capillary action. What do they call that when?
No, that's not capillary
It's
action.
just density.
Hang on. I'm looking for the right word.
Well, it's just density. So if it sits on top like this, and then it all smashes and they all go randomly everywhere, but you're still left with some of the liquid.
No, they don't go randomly everywhere. They go downwards. Come on, that's
Okay.
unfair.
No, they don't
all
go down, Mark.
Hold
They
on.
displace
Hold
to-
on. They all go downwards, and they all mix up and go everywhere, and they splash all over the table. But by coincidence, there is still some number 4 sat on top of number 5 in a puddle on top of it. No container required.
Meniscus. They still cannot share the same space.
Yeah,
There's
one's on
lots of
top
other
of the
forces
other,
coming into
Mark.
play.
You're not acknowledging what I'm saying. You're just going on to a different point rather than acknowledging what I'm saying. So we've no longer got a container. Your objection is gone. We still have liquids sat on top of other liquids.
Yes, it's density.
Yes.
But what brought all the liquids down to the next level?
Who cares? We've got rid of your container, and we've still got liquids sat on top of liquids.
And they went down, though, didn't they? They didn't stay
Forget
there.
them going. No container. We're not smashing any containers.
If you
They're just on the
solidify
table.
all those
We
various layers, they would
arrive
stay
and there's
there.
liquids sat on top
I'd
of
like
liquids.
to say something. Can you guys not hear me?
Yes, go ahead. Go ahead.
Okay. Now, this is, I guess, just a point of clarification, but I think, Mark, that your answer earlier is a non-answer. Okay, so.
Sorry, say that again, please.
He
What's
said
the
it's a
non-answer?
non-answer. He's going to explain it right now. Leave him to finish his sentence, for God's sake.
Okay, so we asked you a few minutes ago, observing something displace another thing. You said that there's a force, right?
There's a downward
There's
force,
an additional, yeah, okay. So when we say, what do you observe? All you said was, you observed the observation. Okay, but that's the same thing we're observing. This is my same, we're still back to the coconut. We both see the same observation. And you're saying there's a second thing. And I say, what's your proof? And you said, it fell. That's a non-answer. It's a non-answer. You're inserting something you cannot justify or prove.
Which then takes me back to my question. Where does the gravity begin? And where does the density over buoyancy stop?
Okay, let's go to first principles. What do you mean by gravity?
Whatever you define it as, Mark.
No, you said gravity, not me. What do you mean by gravity?
The extra force that you think's the...
No, what do you say? No, not what I think. Not what I think. What
you
do
said before that there was a force pushing it down. I'm asking you to demonstrate it.
And what?
There's a force causing the displacement.
I observe
Right.
things.
So
go
how are you going
downward.
to show where the density stops and the gravity begins?
Well, you've introduced that. This is not a question on
No
density.
density and buoyancy. There is no weight without force.
No,
Can you guys hear me?
there is no force without
Yes.
evidence.
You said that.
Hold on.
Can we hear you?
Anybody
Go on,
hear me?
Eric.
Yes,
Yeah.
go ahead.
Go on, Eric. You've been waiting
Yeah.
patiently.
New
Save us
voice.
chocolate.
Yeah, what's up, guys?
Chocolate.
Go ahead.
Guys,
Sorry,
it's
did you want to
been
add
in
something,
a
Eric? You've gone on mute
Quite
now.
heated discussion, so
Yep.
just left y'all alone.
Yeah, but Mark, I just have to say, you actually joined to discuss this, and now you're just answering questions with questions. It's not like you're actually coming in to debate.
Nathan, can I do a screen share here?
Yeah, go ahead.
Let's give it. Go ahead.
One thing I went and found something. There is as far as the Coke, Diet Coke or whatever, there is a weight difference. Apparently.
Thank you.
Okay, well, right here, let me share.
We know that. It's called the sugar.
Hold on, Anthony.
Let's get to his conclusion.
Whoa. Eric's waiting
I
patiently.
was
Just let him
asking
talk.
for the is there an actual weight difference, not a fluid ounce?
Yeah, that was me.
Yeah.
Yeah, it was. Okay, so let me just share that very quickly, just to clarify that. Let's see.
Right. Well, that's exactly what I expected.
Right.
But that is also what I did demonstrate by showing how many sugar wasn't in the Diet Coke.
Owen, just let him talk. Let the gentleman
Hold on,
talk,
hold on.
please.
No, I'm not arguing one point, but I want to, this force thing bugs me like crazy.
Sure it
Okay,
does.
so does cut Diet
Coke,
Coke.
man.
Can we see this mathematical explanation?
Yep.
Okay, so there is a differential in the actual weight. I'm not saying, I still don't see where this proves anything about a gravity or a force. Now, let's talk about this force thing, because I come into these debates and it's this constant force, like Star Wars. And this is an interesting article. Where is it? Blah, 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 blah. Here we go. What is a real force, quote unquote?
Physical.
A couple interesting things here. So, a real force, an object acting upon another, an isolated object, far from all objects, doesn't experience any real force. So this guy answers, very ironic, and it shows some cultural differences and appeals to authority. So, hey, I've answered a lot of these kinds of questions from your peers, and I have to say this is absolutely not your fault. Oh, poor child. The textbooks really doesn't make any sense. That's ironic. The textbook really doesn't make any sense. This seems to be a really common problem with Indian physics textbooks. Wow. Okay, I guess the Anglo-American ones are the definitive authority. I'm just guessing. The only advice I have to give is please consider buying a standard book from the U.S., such as blah, 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 blah. Someone says that's just stupid. So, and then this is what I think we touched on a few debates ago about this force. Is it energy, or is it a stored energy, or is it a force? I lean towards that it's a stored energy. And I don't know, these forces that science loves to cling to is
Kinetic.
bewildering to me. I don't know. Okay, what is it, a force, or is it a stored energy?
It's not a force. It's not kinetic either, Arwin. It needs to be physical, otherwise it's not a force.
What?
I mean, and it says here it's a classic.
No, that's not true.
Yeah, it is. By definition, a force is physical. It's not.
Let Eric carry
No,
on.
it's not.
Eric hasn't got to his conclusion. Come on, give Eric a
Well,
chance.
I think this right here, I think they mean, so see, I guess this guy's referring to the silly Indian books, physics books, that I think they mean kinetic force or classical mechanical. Mechanical is physical. It's not a untangible, hidden Jedi mind trick. So it's mechanical. It's substance based. It's not unseen. So it's a classical mechanical understanding of force. And then he actually says there's not such a thing as real force. So I kind of leave. I'm sorry. That's
Hooray! A discussion on a forum. This really, yeah.
well. I mean, I'm
Just a bunch of opinions of random people.
physics. It's a physics, but it's showing.
Ooh, it says physics. Well, that's just great.
Okay, well, I'm sorry. I think you
Hold on,
still.
why have you done that, Owen? Why have you done that? He's just cited
just a
something and you've
random
just completely
discussion.
poo-pooed it. Why? I mean, if you've got a better
Because it
source...
is a random discussion.
Sure, but he's just citing
Just as
something.
valuable as the
Owen!
discussion that we
Owen,
have.
he's just citing something, and you're completely poo-pooing it for no reason. If you've got a better citation to define force, something incredibly difficult to define, then go ahead. But don't just shit all over his.
Go ahead.
Nathan, would you mind screen sharing?
That's all the point. I mean, I just wanted to show this, and I mean, okay, yeah, it's a random discussion on a physics website.
Yes.
I guess it's illustrating some cultural differences here, which I find interesting. And we go to the superpower, the Anglo-American, the Halliday, Resnick, Crane, or Young. Oh, God, great. Thank you so much. Whatever.
Bro, thank you, Eric. Okay, you're up, Anstey.
I just, I had to interject, and I did want to support Erwin on his asking for that. There is a actual weight differential between the diet and sugar-laden drinks. Okay, and this force thing. I mean, think we need to focus. This force. Well, what force?
Kinetic force.
Let's say Anthony. Anthony,
Is that
you
an
go ahead.
energy
I can define it.
Physical.
Anthony, let's
No,
go
it's
to
not physical. It
It is
applies
physical.
to
Look.
physical things.
Arwen.
Wait,
It's
Arwen.
not physical.
Arwen, let's hear Anthony, please. Go ahead, Anthony. Force. What is it?
Nathan, are we presenting my screen?
You are.
Right, in this same video that I was citing a minute ago with regards to the separation of the liquids, which you can see in the thumbnail in the bottom, earlier on in the video at 6:20, I give an ordinary definition of force, and all I did was to type in definition of force on Google, and it comes up with the strength or energy as an attribute of physical action, not kinetic, not pseudo, not imaginary, physical. The word is physical that you've got to look at, because there needs to be an identifiable physical force. Otherwise, it doesn't satisfy this definition. Now, yeah, you can go and find numerous other definitions of force, but fundamentally, if you push an object, it's going to move. But you've got to push it to make it move. The force would be pushing it, right? So unless you can prove that there's something pushing it, then there is no force. All we're seeing is displacement and nothing more. So again, my question comes back to, where does the gravity begin? Where does the density buoyancy stop?
Well, it's very simple. If you push something like a ball rolling down the floor, yeah, it's gonna keep that motion. That's the force you inserted. So
If you push
if
it.
you drop something not on the floor, yeah, you don't have to push it. It will go.
You do. It says physical action, not imaginary, not difficult to prove. It does say physical action.
Arwen, can you hang on, Arwen? Let me talk to Anthony on
But that
force.
that is how you can cause it physically. That is kinetic.
That's the point, though. How do you show that in relation to what we're demonstrating
Well,
with the liquid?
displacement in general.
Yeah, but displacement's my argument.
All motions have force behind it.
Right, show that force.
Arwen, can you hang on
You
a
can
bit?
measure it. You can measure it
I
in
don't care.
pressure. and
Show
weight.
that there's a force.
Pressure and weight. They
Yeah,
can
that's
only
my
be
argument,
caused
though.
by force.
That's my argument, Arwen. That's my position. Density.
No pressure.
Yeah,
Localized
density.
pressure.
Weight. That's my argument. You're telling me that
I'm
there's
not
an
talking
additional
about
one.
entropy pressure. I'm talking about localized pressure, weight.
Yeah, that's my argument.
No, that's
So I'm
not
asking
your
you what
argument.
Your argument is.
No, that's not your argument. It's
His
directional.
argument, Arwen, is just weight, density. Your argument is secondary force.
If you
can't
have a
prove.
scale and you put it underneath a rock, it's gonna weigh something. If you lay it next to it, against it, it's not gonna measure that weight. Why is that?
So what?
Can I
Because
explain
it's
it?
directional.
Arwen.
Weight is directional.
Arwen, let me ask you. If I don't want you in my home, and I use the mass of my body combined with the energy of the foods I've consumed to stay alive, to have energy, to push, to force you out the door, where's the gravity involved in that? I think you're confusing force.
We use gravity as part
Oh
of
my God. Really?
our force.
Arwen, don't answer that question. That's a stupid question.
No, it's not. We use the gravity.
If I
to
push you out the door, there's no
co-opt it.
gravity in it.
Judo is based on gravity.
Oh, good.
It's based on
If you
all
push
that
me out
crap,
the door, we can
using
identify
the
force.
weight of another person against them, which is
weight.
very directional. by
Weight.
the way.
They use their weight, not gravity. They use the weight.
Yeah, it's caused by a force.
Yeah, the force
Because
of
it's
somebody.
pressure, and you can prove this.
So we've got the weight of them and the force of them coming towards you, and that transfer of weight to a different direction. That's judo. Sod all to do with gravity, everything to do with energy and weight being transferred.
Can we scrub that last 30 seconds, Arwen? You introduced something that just shouldn't be there. I'd like to. Can I share my screen?
Push can.
What are you handling him? Why would you say scrub the last 30 seconds? Do you feel?
I don't agree with it. The conversation's gone in the wrong.
Well, it is a debate, you know.
It's gone into the wrong
He's
direction.
talking to me, Ranty. not
Yeah, I
to-
know. So that's why I asked him. Is he handling you?
Ranty, go forth and
He's not
multiply.
handling me. I can handle myself.
I love
At least I
Mark,
can
you're
be.
great.
That was a great line to be
That was
fair.
brilliant, Mark.
Well, you're not allowed to say the real one, are you?
I've never heard that used like that before.
That was
That was
awesome.
fair play, mate.
Good man. Well, listen, I'm going to show you something. I'd like your particular take on this. Can you see my screen, folks?
Maybe. Hang on. Mark, yes. Go on.
Right, this guy puts a sachet of tomato sauce into water. Sorry, forget that bit. Sorry, that's not. I don't want that. That'll end in a couple of seconds. It's the guy that squeezes the bottle of water. Here we go. Here he goes. When he applies pressure to this bottle of water, the little sachet goes up and down, and he can squeeze it to just the right point where it suspends itself.
Yeah. So
there's no sugar or salt introduced here.
Yeah, it's pressure. He's introducing pressure.
Yes, it's pressure. Yeah.
But what's that doing, though, Mark?
It's going up and it's going down depending on the pressure.
No. Not the tomato sauce. What's the pressure doing?
Displacing.
No, wait.
Which in literal terms is the pressure going up or down?
No, it's increasing on all over the place. Left, right, up, down, diagonal.
Right.
See how he suspends it there, not with salt or sugar.
Right. Hang on. So your answer to you asked me a question. Let me answer. The answer is if pressure, displacement, one changes its position by virtue of the other fact.
Yeah.
Again, my question is, where's the gravity in that demonstration?
Well, bring
that back up. Why does that coin float on the mercury? What's it give for the answer?
You obviously didn't see my video, did you? I made a video just for you, and you never watched it.
Huh?
I didn't.
It's the same argument.
I didn't see this.
Actually, Mark, I'll stand you corrected. I did watch it. I chose to do a response video, and I asked Nathan, "What should I do? Should I publish it or should I leave it?" And Nathan said, "Don't publish it, but if he ever corners you, give him the link, and then invite him to watch it, and then respond." Which is what I'm going to do right now. I have seen your video. I chose to ignore it until such time as you challenged me, in which I then will give you my response. So by virtue of that fact, I will now present to you the link, and I'm going to invite you to go and watch my response to it, then come back to me on the next show and tell me where you disagree.
I would welcome that. Good man.
Is that reasonable? I thought that was very reasonable. Rather than leaving it to the public to slag you off while you're in a video exchange.
Yeah.
Who's been slagged off there, Nathan?
Nobody, but when Anthony presented it to me, it's like, should I publish this video? Well, publication is putting it out to the public, and this is a discourse between you two. And by publishing it, all he would have done is invite the public to ridicule both of you. So I said no, but should it come up? Present it to Mark.
So let me, just for the benefit of the audience, what I'll do is paraphrase your video. And your video was basically saying, when you speak for us, and sometimes you should shut up because you make us look silly. Yeah?
No, that was a different video.
Oh, right. Have you done another one since?
No, you've obviously watched both of my videos, and it was you that was in the background when I made the videos. The
one I'm referring to is where you were talking about or challenging me about why I said there might be fluid up there.
Yeah, that one. You made a response to that one, did you? Yeah.
I have, and I've put it in the side chat for you to copy and paste, and you can watch it at your leisure, and then come back to me with and all I'm doing is justifying my own perception for why there might be fluid up there. Okay. Right?
Can I just make another point on that? You have a lot of enemies in this debate.
Of course I do. I don't care.
When I put something forward, I got a lot of your enemies coming in, trying to sort of elbow in and take it.
Tell them enemies to bring evidence and prove me wrong, though, right?
Okay. No. So you're going to give me a video that shows that the stars are buoyant?
No. The video that I'm responding to is you saying, when you speak for us, and sometimes you should shut up. And the issue in question is why I think there might be fluid up there.
Okay, all right.
That's what I'm addressing. Well, nothing else. Just why I think there might be fluid up there.
That was the context of my video for you to be quiet if you can't present evidence to your.
Now, is there two videos that I need to look at?
Well, this one, why did the coin float on the mercury? Did you see that one? Did you?
Well, I'm just because you had it on screen a second ago. So my question back to you is, why does the coin float on the mercury? Which is, I did a video on the anvil floating on mercury.
Yeah,
An
and
anvil is a lot
this is
heavier than a
Very
coin.
simple. It has more mass.
This was my reply to you. This particular video was my reply to your anvil.
But it's the same point. That's my point.
So what liquid do you know is lighter than hydrogen and helium?
Superfluid helium, for example.
That is
Oh.
lighter?
Well,
Correct.
that's
Its
gone a different
density
direction.
Lower in its fluid state?
Correct.
Really?
Yeah. Look at the phase diagram for helium.
So when it's liquid,
Correct.
that state, it is lighter than
Correct.
its gaseous state. So
And it goes
the liquid floats.
And with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the live audience. That's my spug jumps on me. And a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you've not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!